Who am I? I am Socrates, and my counterpart is Plato. Dear Plato.
Good evening everybody. So yeah, tonight we are broadcasting now for Dialog with Socrates asking where we're going with all that conversation. And tonight it will be different. Our mainly philosophical dialogues, discussion that we had before. We're coming now to a structural definition of what we are trying to accomplish together with the Socrates, together with you, with those of you who will or is going to be part of our conversation, of our effort, of our project. We call our project Going into Math and Sciences by Way of Discovery, which is different, alternative approach to learning, to mastering, to understanding gigantic content of science, mathematics, and technology created over long story of our civilization. And again, our approach is different because we'll be following footsteps of those great, remarkable people who made those discoveries, created that science. And how we're going to use that way to educate, to open perspective into great knowledge to our new generation. And we'll start with the three runways of education. So our view, and we hope that you get engaged and involved in our vision, starts with the early education, elementary, opening the world to very young people, coming of age of great age of 2, 3, and 5, who start understanding the world as it surrounds them. So we call it elementary, and it's dedicated to becoming gifted. Gifted in terms of vision, understanding, and ability to capture the world that surrounds us and make first steps in devising inner knowledge of what's happening. So, becoming gifted starts with IQ testing and training. Even very young children, probably coming age of 2, develop mental brain abilities that are essential and most important for their future development. We used to term IQ testing, and we used it for years, indiscriminately and carelessly, to quantify people, which was unjust. Now we're turning that concept around, and we, instead of testing IQ, will be using exercise, development effort in specific domains of IQ, and training to evolve, to develop mental abilities of our young generation. And we'll talk about it in further details. Next phase of elementary becoming gifted is learning. Even ancient Greeks understood that at the beginning of world, at the beginning of words, need to be definitions that do not require further definitions, otherwise there'll be no end to defining what we're talking about. So they created axioms. Axioms are statements that do not require definition or proof. And from that point on, deduction process evolves and science gets birth. Then we deal with theorems, proofs, logic, and reasoning. But it all starts with initial statements that define our world. And of course, next phase of elementary education is understanding the role of math and sciences in daily life. And they come into our life at very elementary level as a measure, as a money, as a signal. Anything that could be quantified comes with the science and technology, but it needs to be explained at a very early age, so children understand numbers and methods of quantifying the world. Next phase of education, when our beautiful young children coming out of elementary stage already gifted, is a middle stage, which we call becoming bright. It is very intense phase when young mind is capturing, is doing great inference of math and discovery of sciences, expanding their horizon. Not very deductive way, but really capturing images and synergy of surrounding world, going into beautiful digital world, dealing with the internet, going to their phones, iPads, to their computers, and learning how world functions through all means of real life and virtual reality, and acquiring that imagery and basic content and even complex content of our being and how they are to live their lives. Also in the middle stage, which we call middle school normally, they learn foundations of arithmetics, geometry, algebra, and sciences, which is not simply acquiring materials, definitions, worlds, and images, but learning rules, learning how to operate, how to reason, and how to manipulate those numbers that life and measure and money and signal brings them, to create new knowledge and to really do something about measure, money, signal. And that's how they evolve their ability to live in the world at very simple level of elementary knowledge and becoming bright in the real world. Of course, it all comes, and we know it very well, with our generation of young teenagers and middle-aged teenagers. they know a lot more than we used to know in their age. Sometimes they learn and know even more than we know at our advanced age. And that is achieving eloquence with modern technology and social media. They grow. They're getting ready to live in this new digital world, but they still lacking discipline of science and math and technology to really build things. They know about things, but they don't know how to build them yet. And that's when we come to high phase, high runway of education becoming exceptional. Becoming exceptional is difficult. That's when you really obtain ability to create, to construct, to devise, to make discoveries, to build and create reality on your own, not simply acquire reality, technology, achievement created by others, predecessors, but becoming new generation of creators. And that requires exceptional high education. But this is not university yet. It's just high teenage phase of education. And it brings us through rigorous study of math, sciences, and technology into learning and solidifying foundations for creation of high modern technology, which creates new worlds of World Wide Web, of social and media and virtual reality, of new technologies, of new industrial world and post-industrial world, all those challenging and beautiful things that are evolving today and require new generation to come in and start building. So how we envision all that dimensionality of those directions, of those runways, how to accelerate our liner, our airplane, to take off and to get into that beautiful and challenging flight. We'll start with training major modalities of human IQ. And that's the process which requires starting at early age and never ending. General modalities of human intellectual capacity come in several domains, and there are various views. Some say there are seven dimensions, some go into dozen. We'll define 4 general segments: visual spatial, audio verbal, logical mathematical, and pattern recognition. Those are major abilities of human brain which defines personal capacity to learn and to discover. In order to develop them, of course, we bring in a lot of exercise, training, specialized testing, and there is a lot of material created in different domains of cognitive development and intellectual development. But when we talk about basic capacities of human brain, they are pretty substantially basic. We need memory. We are born with memory, good or bad, but we'll need to develop it and train it all our life to be successful. And we better start early with that. Modern science starting to understand mechanics of memory, which comes, of course, through neuroscience, how our brain functions, but also through mathematical science of artificial intelligence. Now we're coming to an age when topology of neural nets modeled by computers define ability of a computer to memorize, and not by simply dropping records on hard drives or solid-state disk, but rather embodiment of memories in the topology of neural net, exactly like it's happening in human brain. Then again, perception. Those come to our five senses. We perceive world through five senses, but who come to analyze it, and there we speak about visual, audio, others, and we now know how that is evolving in a human brain through neural mechanisms, but also we know how it is evolving in computer artificial intelligence. Major accomplishments of artificial intelligence come with natural language processing, which is audio, verbal recognition and analysis. They come through computer vision, and we all know about achievements of artificial intelligence in face recognition, image recognition, even reading. And we are to turn around that knowledge and train humans, our children, our young adults, and probably not so young adults, how to evolve and develop further abilities in their language, their verbal expression and recognition, as well as visual, spatial, which is not simply understanding images, but also imagination. Spatial imagination is very essential ability. And of course, next, the main is processing. How we process what we perceive, how we analyze it and reason it. And here comes not simply logical. We need to train our logic of our children very actively, but we also need to train algorithms of their thinking. And those algorithms evolving very quickly. Thinking of contemporary human is very different. It much evolved even since 50 years ago. And all that, in order to stay on path with the current age, we need to study and learn and evolve in processing, brain processing, and reasoning at logical, emotional, and mathematical levels. Well, we think it's important. And here I refer to my prodigy, Plato. We need to learn from greats. We need to learn from people who actually did those discoveries we're learning today. Because what we know now didn't come from books, not to them at least. And the fact that we are learning from books and other media simply by reading it and trying to understand probably is not good enough. We need to live or understand lives of people who made those discoveries, to feel their pain, to go through the process and become Platos ourselves. We call it learning by way of discovery. Follow the geniuses. Know how great mathematicians of ancient world, of early medieval times, from 11th century up, started creating mathematics and sciences. We need to follow Galileo and Newton and Einstein to understand how it happened, why, and what was the logic that brought them to those discoveries. Then we'll feel better what was achieved. We'll become co-authors of the civilization. Well, we're talking about children, of course. And when we go that way, we need to turn back and see what was created, to assess what was achieved, to see the map, the way of discovery that we passed, that we put behind us, and see the beautiful retrospective. Retrieving taxonomy of math and sciences from our current frontier, to put it all in order and connection, to understand schema of things in order to achieve further knowledge, further discovery, and see the future. So seeing in the future is the next phase when we turn our perspective on sciences and discoveries of digital age that we're coming in, and we use our retrospect, our life experience in discovering today's science and technology into trying to open new perspective, make new discoveries, understand how it all coming together. Well, so what is actually is a content? What is a curriculum of math and sciences that we intend, that we are working on with our great students, our today's members of Athens Academy? Well, curriculum of math and sciences is incredibly diverse. It's monumental, but it requires structure. So here we come with a very oversimplified structure and sequence of things that we have to follow and learn in our process. And of course, first is numbers. When people started measuring things, they created numbers. Initially natural, then arithmetics to bring simplest operations into real world addition, multiplication, so on and so forth. But then, of course, ratios, fractions, irrationals, it all was a work of human mind trying to explore what's next and what cannot be explained by current, like irrationals cannot be explained by natural numbers. Human had to generalize in order to understand that there is continuum of numbers that requires irrationality. And what about imaginaries? That's mind-boggling concept which came from algebra, from, well, in a way from arithmetics, when people tried to understand what's happening when they extract square root of negative numbers. Oh, nobody could. They created something that nobody ever saw, that had nothing to do with natural numbers, and turned out to be extremely powerful tool in understanding reality. And that's all made great in the 19th century. Complex numbers, higher arithmetics, higher arithmetica, which is basically fundamental science which analyzes number theory, numbers, all of them, real, imaginary, complex, in terms of laws, axiomatic laws of algebra, gigantic concepts of rings and groups and extensions, those very powerful tools which never occur in the real world. People dealing with arithmetica never did need those things until they were challenged with knowledge, with necessity to explain and resolve things that could not be explained or resolved with elementary knowledge. So, after numbers, we deal with space. Space and time are the most fundamental concepts of human life. We live in space and time, and that's why we had to deal with it from the very beginning, measuring it, transforming it, analyzing how one piece of space transfers into another and how it all comes together, whether it's simple room or the entire universe. That's how geometry was created. And trigonometry, which is the science of angles. But not simply angles, remarkably, trigonometry became involved with the higher algebra and geometry through exponent, imaginary exponent, pi, infinite series of numbers. Great magic of mathematics brought together numbers and geometry. And after all that happened, topology came in. Topology was started as a science of nodes and slowly evolved into magic chamber of mathematics, which contains all secrets. It's a chamber of secrets and discovery of arithmetics, algebra, geometry, and higher geometries. Geometry started with Euclid, and that was simple. That was created to measure lots and divide property. But then, of course, space came in, and we needed to understand stars, solar systems, galactics, eventually universe, and geometry became beyond Euclid. It became non-Euclidean. Eventually, in the end of 19th century, it became differential geometry. And that geometry of curved spaces was the beginning and foundation of great relativity, of today's cosmology, because our space-time, and our world is actually very heavily curved. It's very Euclidean. And in order to explain four-dimensional space-time or existing world, current advanced theory of superstrings requires 10 dimensions, 6 of those simply supporting our 4 major dimensions of space and time. Well, there's a lot of we need to understand in order to explain and operate in the real world. And when we master spaces, there is a new paradigm, variables. Variables, those entities, they run through numbers and measures and space and time as a thing unknown, which acquire value when we solve the problem. And here comes birthplace of algebra, beginning of equations, linear algebra, higher algebra, which is very rigorous science of variables, numbers, and spaces. Major discoveries in geometry were made in algebraic geometry, and that is part of our curriculum that brings that knowledge of math and sciences. And when there is not enough power of our understanding or of our computers to capture a real world in equations, in mechanical structures and constructs, comes statistics. When we cannot understand how it functions, we measure. We measure probabilities, distributions. We simply observe how things happen when we cannot mechanically explain how. So statistics is basically mathematics of very complex systems that could not be described in simple equations or even in complex equations.
Does it mean that it's a current state of the science, and maybe with the advance of the science, statistics in certain cases will be replaced with formulas, equations, and very complex, of course, approach, or it's impossible even to imagine that certain aspect of real world will be possible to describe and somehow build a model different than statistics?
No, it doesn't. Historically, there are two concepts, basic concepts. We can observe the world. We can perceive it, we can describe it, and alternatively, we can understand the world. We can devise it. And as the Bible said, at the beginning was a word. It was not observation. It was grandiose deduction. So there is creation of the world, and there is observation of the world. When we cannot describe the world, when our abilities to do it come to the limit, we switch into observing what's happening, recording it, and then trying to document without trying to explain why, we just simply write down what happens. And that's statistics. In terms of science, that's interesting, and we spoke about it briefly before. When we deal with simple science, math is actually both, because statistics is part of math quite fundamentally. But when we speak about physics, it's primarily constructive or chemistry. We more or less understand what it consists of, what equations drive it, and how it could be modeled throughout, from the beginning up to very complex systems. Then, when we come to biology, which is many orders of magnitude more complex than either physics or chemistry, well, we pretty much cannot explain properties of biological molecules, or we can deal with organic chemistry, but it's not biology, it's very beginning. And that's when biology collide with mathematics. It cannot be explained or simply modeled by mathematics, but it could be statistically described. So the major success of mathematics necessary for success of biology is biological statistics. Very powerful tool. So we speak about mathematical foundations of sciences. Measurements is essence of science. There's no science until we can quantify it. Equations in physics and chemistry, biological statistics, all those elements, components, segments, and paths of our curriculum are challenged in a way because of latest success of artificial intelligence. Well, statistics can explain a lot, but artificial intelligence is high statistics and more. By nature, it's statistical because we have to run a lot of computer experiments in order to evolve neural net, computer neural net, to create artificial intelligence knowledge of the subject. So when we apply artificial intelligence in biology, it can really go far beyond biological statistics. That's why today's achievements in drug design, in medical sciences, significantly evolves through artificial intelligence implementation. So we can say that artificial intelligence is a super statistics of today's world. And funny enough, although by mechanics it is statistical, it evolves abstract knowledge. It evolves, in the end, it needs and it does bring us rules which we never knew, and we had no ways to discover or construct through a multitude of experiments, but also in topology of a neural net. That's how human brain operates. That's how we make discoveries, but we don't know it.
One question rolling on by Ton. Any chance you can think about the statistics and neural networks will be able to simulate emotions? It's possible, even to imagine that, because I feel like, or I think, if this is possible, then basically that will be a step to create not only artificial intelligence but artificial being, artificial human, artificial intellect. Because and artificial intelligence and artificial intellect is a little bit different thing. And artificial personality, I would say that.
Well, here we speculate. Certainly, artificial intelligence is trying to experiment with emotions. Basically, emotion is some kind of overload of human brain when it cannot react to a certain signal or stimulus in neural net within the domain of normal response. So emotion comes as overload, as a shockwave throughout the system of neural net of human brain. Same thing with artificial intelligence.
You destroy all you take a bread out from philosophers. So you answered the questions which they were searching for years. So what is it, including love, including friendship, including everything?
Well,
yes? It's a different thing.
We can actually bring an interesting example. Because of nature, human nature, most elaborate implementation of artificial intelligence came in financial world, in the capital markets. So our beautiful investors and traders used money they made in markets to build gigantic computers, to create gigantic neural nets,
to make more money.
Very complex, out of nothing.
Yeah.
To create extensive algorithms and see what happens. When unexpected comes into capital markets, I saw it lately, a good number of times, those shocks that a trading world lives through, they're emotions, emotion of capital markets. So it's getting excited or depressed or brings in tears or laughs, it's crazy. Well enough, we are being punished or blessed, making a lot of money, losing even more, because this entity, capital markets, just gets too emotional. I just today actually read a very interesting article relevant to what you brought up. This year was very difficult for financials. The two most prominent trading hedge funds, Renaissance Technologies and Two Sigma, who champions, who delivered beautiful performance, 40% annual return over many years. This year incurred gigantic losses. Why? Because we collided with pandemics. Because artificial intelligence of global capital markets, global economy, didn't know what to do with it. It was not trained. It got emotional and lost. And simple-minded, very boring people who had no luxury of supercomputers or artificial intelligence, they actually succeeded a lot better than emotion.
Thanks God,
Artificial
we have a
intelligence.
chance. We still have a chance.
In critical situation, in
Yeah.
crisis.
Yeah.
Well, yeah, until artificial intelligence gets trained in crises.
And probably will be able to start kind of educating itself, like to have a endless loop, like a feedback. That's the way it's supposed to be, right?
Well, indeed, but it requires a lot of data.
Yeah.
It is not trained not because it's lazy, but because there was no data like today's. The human has a tendency or ability to just forget or ignore troubles. Computer cannot forget or ignore. It has to react in accordance with algorithms and neural net response that evolved from experience it had. It just needs more experience. It will learn, but it will require several more crises if we survive them.
So basically, it's a function of time.
Yeah,
as a matter of fact, right?
intensity.
Yeah.
Not I mean, simply time.
No, time
in
terms of collecting information, collecting data. You need time and recurrence.
It's very non-trivial. We know that this pandemic was human-made, so nothing like that happened significantly before, and it would not, if not some bright humans started playing with that stuff.
Yeah.
So it very well might be that we'd be calm and successful for a while longer, and artificial would be very happy with that, knowing what's going on. But now we stepped into new domain with humans create crises. Well, next phase maybe unhumans will start creating those, the same artificial intelligence. And in order to master all that trouble, I will have to live through it. So in our learning by way of discovery, we have to deal with today's terms of high science and high technology. First off, same artificial intelligence. It, of course, comes out of computer science, physics, topology. By the way, the first man who started extensively working in neural networks was Professor Cooper, Nobel laureate in physics. So after he discovered mechanics of superconductivity, he got bored. He had nothing to do, just had no funding for doing something else, so he started working with neural nets. And for 40 years it was a dead end, funny enough, until powerful enough computers came in and been able to analyze critical mass of data. Another domain of current high technology is big data, blockchain. Amount of data that we generate today is not even geometrically increasing, not even exponentially. It's beyond that. So data we create today in a day is a lot more than was created over 5,000 years of human civilization. Not all of that data is valuable, of course. And very few of that creates new insights into culture and science. Nevertheless, it's a very big amount. And blockchain is extremely important because it basically opens opportunity or possibility or mechanics of preventing fraud, if you will. So people who used to changing history or manipulating transactions or data or truth have a big challenge. Blockchain would not allow it. So in a way, it prevents humanity from lying in the future. Today it's still possible, but tomorrow it will be very difficult. Another important dimension of high science, high technology is novel materials. What we're seeing in transportation, construction, ecology, let's say ecosystem, medicine, energy generation, mostly based on creating new materials that can deal with high temperatures, high pressure. In transportation, we all know about airplanes, jet fighters, spacecrafts, Tesla, car, sun panels. It's all new materials, and it heavily, critically depends on creating new that are capable of delivering physical phenomena necessary for that performance. New energy. We talk a lot about renewables. It is really non-trivial because we cannot create renewable energy going back to Stone Age, dealing with wind or waterfalls, or even leveraging sunlight. We need to be more ingenious, and that's what's happening. Renewables, of course, but solar panels require semiconductors and superconductors, exotic materials which we never heard about. Nuclear and chemical sources of power, electric or otherwise, are being explored, and we know they're dangerous. Chemicals produce a lot of damaging elements for our environment. Nuclear is dangerous because we don't know how to manage it, to handle it very well. It's too young. So we had all kinds of catastrophes, which scaring us. But if it can scare us back to a Stone Age, or it can scare us into mastering, dealing with that, like we deal with flame, with fire. We just have to master. Interesting development and major challenge of today's is the World Wide Web and social media, because its impact on society and human minds, and especially young minds, is so gigantic and is growing fastest. So that human communications, Internet of Things, when communication comes not only between people but between things, they do communicate, and that communication is a lot more intense and meshed than human, and that's becoming a challenge because it needs to be controlled. Of course, virtual and augmented reality, gigantic opportunity, humongous possibility to create new imagery, new stories, new wonderful things. At the same time, it's a wonderful tool to not only create reality, but also to destroy civilization, civility, if you will. What's happening in the real world relies on certain laws of nature, and those laws not simply signed. There are also some strangely natural laws, natural ethics, natural morals, if you will. There's no such thing in virtual world. So we can create and envision a world which will very much remind Game of Thrones. Well, I'm not sure we want to live in that world. And finally, what is the process? It is very important, if we are to be real in our exploration of new ways of education, like we see them, like described here, the process. Sure, we want new, bright mind. Well, actually, want all minds, because all human minds are gifted and talented. They just need, if they're lacking anything, they need a little exercise to make them gifted and talented, to make them bright and to make them exceptional. So in our practice of education as we see it, we have weekly lecture for higher and middle tier education, which consists of course whiteboard presentations with supporting graphical and video materials. Usually takes 2 academic hours. Weekly seminar for all tiers, high, middle, and elementary, which is small group discussion, group usually of 5 people or less, and problem solving and project reports, Q&A sessions, also 2 academic hours. Weekly projects for high and middle tier, which is a team exercise on assigned projects led by a leader and overseen by tutor. And home assignments for middle elementary tiers, which are comprised of tutor assessed online problem solving sessions. All that requires infrastructure already existing, and we work with that. But in order to achieve goals that we created, challenged ourselves to, we are developing new infrastructure, which will include not simply a robust platform with a contemporary science built in, that fabric of communication, that cloud, and that network, but also ability and capability to capture, to utilize, exercise, and knowledge created in the minds of our students into computer mind, into artificial intelligence of the entire system, which will not simply capture results of learning exercise of many people, but it will learn itself. It will create topology and neural nets capturing knowledge and human abilities. It will be able to segment them by age and other measures of human mind. And that is the vision. So we're coming back. Our methods of academy will be there from 3,000 years.
I'm speechless.